Okay guys, so now I want to do a couple of color code examples. So the first one, we're going to use the 5-band resistor from the color code picture right here. And I told you last time it has a it has a narrow tolerance, but it reads exactly the same way. So first you got your first band and it's red. In the first band column, if you look at the red, the number is 2. So I put down 2. Then I look at my bands again. My next band is, I believe, orange. When you look at the orange column for second band, it's 3. So I put down 3. Next one, I look at the next band. Now, this is my third band. I need to check, is this a 5-band resistor or 4-band resistor? If it's a 4-band resistor, then this is a multiplier. But this is not a 4-band resistor. This is a 5-band resistor. So I look in the third band column, and I have violet, and this is a 7. So just put in a 7 here. And now I'm going to look at the next band. Now the fourth band in 5-band resistor is the second to last band. So it's multiplier. So my multiplier is times 1 ohm. Okay. So times 1 ohm. So that comes out to 237 ohms. Now let's check the last band, because that will give us our tolerance. Let me take a look. And the last band is brown. And brown means 1% tolerance. So it's with 1% tolerance. Okay, well now let's actually compute the region in which this resistor value can possibly be. So first I need to find out what is 1% of 237. Well, this is just 237 divided by 100. So it's 2.37 ohms. So now I'm going to find the lowest actual value. So this is ideal value minus tolerance. And in this particular case, it's 237 minus 2.37. And that comes out to 234 let's see, 0.63 ohms. All right. So now that's our lower bound. So let's find the highest actual value. And once again, it's ideal value minus tolerance. So in this particular case, it's 237 plus 2.37. So in this case, it's 239.37 ohms. So this time our inequality looks like this. I have 234.63 as my lower bound. Then I have the actual value, which could be any value in between, right? It could be 236, it could be 238, it could be 239, it could be any of those numbers. All right, so this is our actual range. You can see that this is a very, very precise resistor. The difference is really is just a couple of ohms either way. Okay, so let's look at our another example. And this example, I'm going to use this resistor right here. And you can see it's a 4-band resistor. I have those in the classroom. It has an orange, white, brown, and gold band. So this is orange, white, brown, and gold. Now, how do I know which end is which? Let's say you grab a resistor out of the bin and you don't know which end is which. Guys, the last band should give you a dead giveaway. A gold band can never ever be first. Okay? Either gold or silver cannot be a first band. So, orange corresponds to 3. Now let's take a look at the white. White corresponds to 9. So that's my second band. Now my third band is my second to last band, and that's my multiplier. So if you look at the color code, you will see that this is times 10 ohms. So the value of the resistor is 390 ohms. And one last thing we need to figure out is the tolerance. So when you look at the chart, when you look at the chart, you will see that gold is 5% tolerance. So it's 390 ohms with 5% tolerance. All right, so now let's compute the actual region. So lowest actual value is going to be 390 minus the 5% of 390. Now what is the 5% of 390? Well, let's do this. Let's figure this out. So 390, so 5% of, you can use your calculator to calculate this, or you can just use your mental arithmetic. That's perfectly fine. Usually I just go by mental arithmetic. I find 10% of 390 and then I take a half of this. Well, 10% of 390 is 39, and half of 39 is 19.5. So this is 390 minus 19.5. And that's going to come out to 370.5. ohms. So this is my lowest value. And now let's compute the highest one. And this is just 390 plus 19.5. And that comes out to 409.5. Okay. So now I can actually go ahead and write down my inequality. So that resistor, its value is anywhere between 370.5 ohms all the way to 409.5 ohms. So which values could it be? Well, really any, okay? It could be 371, it could be 375, it could be 380, it could be 395, it could be 400, it could be 405. Any of those values, really any number in between 370.5 all the way to 409.5. Any of those values are valid. Okay, so you have to account for, when you're doing your calculations and you're building your circuits, you have to make sure that any of those values would work for your circuit.